Good morning. Today we are going to discuss an important strategic move, which is moving to the cloud. The presentation will cover the basics of cloud computing, including cloud computing service modules, as well as the key security aspects along the way. We are going to highlight the benefit of cloud computing and the shared responsibility of our data's security. Our decision to migrate is driven by the fundamental promise of cloud computing, flexible access to scalable IT resources that can adapt to our business needs instantly. As a Paris and colleagues noted in 2022, organizations are significantly increasing their cloud spending to gain this agility. This model shifts us from heavy capital expenditure to a predictable, cost-effective pay-per-use approach as highlighted by the Nebel and Harris. It provides on-demand storage and computing power without the long leading times of physical infrastructure investment. However, before we embark on this migration, we must thoroughly understand the new security implications that accompany this shift. Our success will depend on proactive security planning that allows us to harness the benefits while effectively migrating the inherent risk. Let's begin with the foundational service model. Infrastructure as a service, IaaS. This module provides the basic building blocks of IT, such as visualized servers, storage, and networking, delivered over the network. As Nabi and Harris explained, in this module, we are the customer. We, as the customer, are responsible for managing the operating system and applications within our virtual machines, while the cloud provider secures the physical hardware. This offers us the tremendous flexibility, but as Paris and colleagues point out, it introduces new vulnerabilities at the hypervisor and virtual machine levels. Because we are sharing physical resources with other tenants, we face risks like VM escape and side channel attacks. Therefore, for this foundational layer, our security strategy must focus on strong isolation between tenants and rigorous constant patching. Moving up the stack, we have platform as a service, PaaS. This model provides a complete cloud-based development environment, allowing our developers to build and deploy applications without worrying about managing the underlying operating systems or hardware. It includes everything from middleware to real-time environments, streamline the coding process, However, these conveniences introduces specific security concerns, such as application integration challenges and the risk of vendor lock-in. Furthermore, the service-oriented architecture that underpins PAS can increase risk from SML and injection attacks, as noted by pirates before committing our development pipeline to any appears solution. We must carefully assess the platform security control to ensure they met our standards. At the top of the stack is software as a service, or SaaS, which delivers ready-to-use applications over the internet. Think of tools like email and Office suites that we access through a web browser. In this module, the cloud provider manages everything, the entire software stack, and the underlying hardware. Consequently, our primary security concerns shift entirely to data and application level security. Nebe and Harris emphasize that while multi-tenancy allows multiple customers to share the same application instance efficiently, it also introduces risk. We must be particularly vigilant about weak user credentials and insecure APIs, which are the most common threats targeting SaaS environment. To make an informed decision, it's crucial to compare these modules across key dimensions. IaaS offers us maximum local control, but that comes with responsibility of securing the operating system and applications ourselves. The PaaS provides moderate control, allowing us to focus only on our data and code, while the SaaS offers the least control, with the provider handling everything. As we move from IaaS to SaaS, our local resource requirement decrease significantly, but the demand for secure, reliable network connectivity remains constant across all modules. Most importantly, as Perez and colleagues illustrate, the overall system vulnerability shifts. We go from worrying about the hypervisor risk in IaaS to managing application layer risk in SaaS, which changes how we must approach our security posture. Two key technologies make cloud computing possible: visualization and service-oriented architectures. Visualization allows a single physical server to be partitioned into multiple virtual machines, creating a pool of shared resources. The hypervisor, which manages these virtual machines, is a powerful component, but as Perez notes, it is a prime target for attackers. This technology enables multi-tenancy, allowing multiple users to share a physical instance securely, complementing this in service-oriented architecture, which uses loosely coupled services to build cloud applications. While this approach approves improves agility, it also introduces complexity. These technologies are foundational to cloud benefit, but they also create critical security risks that demand our constant attention and mitigation. Beyond service modules, we must also decide on a deployment module that fits our business needs. A public cloud is accessible to anyone, offering broad scalability. In contrast, a private cloud provides exclusive access to our organization, giving us greater control. A community cloud is designed for a group of organizations with shared security or compliance concerns, which could be beneficial for our industry. Finally, a hybrid cloud combines two or more modules, offering the best of both worlds by allowing data and application to move between them. As Hansen and colleagues explained, each module presents a distinct risk profile for security, legal, and privacy compliance. Our final choice must directly align with our specific security requirements and regulatory obligations. As we consider these modules, we must confront the key security issues that affect all of them. Data breaches and unauthorized access remains most critical threat. Furthermore, our data privacy can be compromised if providers monitor our activities. As highlighted in the research by Hassan and colleagues, legally we face challenges from uncertainty about data jurisdiction and cross-border data flows. From a storage perspective, robust encryption for data both at rest and in transit is non-negotiable. We must also secure our application programming interfaces, as insecure APIs are a leading cause of account hijacking. Ultimately, we must embrace a shared responsibility module, clearly defining which security tasks are our responsibility and which belong to the provider. To conclude, our adoption of cloud technology is inevitable, but how we approach e-security is a choice that will define our success. A reactive approach dealing with issues after the call will lead to failure. Instead, we must proactively implement robust security framework, which are those from the NIST and the Cloud Security Alliance. From day one, ignoring these challenges will inevitably result in data breaches, costly downtime, and self-reputational damage. Investing proactively in training, tools, and clear policies is far more economical than the cost of responding to a major incident. A strong security posture not only protects us, but also builds trust with our customers and gives us a competitive advantage. Let's commit to leading with security excellence to ensure our cloud migration is a resounding success. Thank you. So the next slide, talk about, the references. Thank you all.